Hello, Algebra 2 students. We are talking about graphing quadratic functions today. This is an introduction to quadratic functions. There's going to be a lot of details about what it means to be a quadratic function. And the form that we're graphing from today is in standard form. The lecture on 4.2 will cover graphing from either vertex form or intercept form. Our terms for the day, like I said, this is an introduction to quadratic functions. So basically what a quadratic function is it is something that could be written in y equals ax squared plus bx plus c. So thinking back to our previous chapter, we talked about linear functions look like y equals mx plus b, or at least could be written in that form. What a quadratic function is going to be, how that's going to be different, is it's now going to have an x squared term in it. So we'll have an x that has an exponent of 2, making it a quadratic function. Quadratic functions, when graphed, make a shape that we call a parabola, and a parabola is essentially a U-shaped function. It'll be a U-shaped if our a term right here is positive, and it'll be an upside down U-shape if our a term right here is negative. The vertex is going to be the highest or the lowest point of the graph. So if our U-shaped, our parabola looks like this, the vertex would be at the bottom here. If it was like this, our vertex would be at the top. All quadratic functions also have something called an axis of symmetry. And this is going to be an imaginary line. And when I graph this, I'm often going to graph it with a dotted line that divides our parabola, our U-shaped graph, into mirror images, or as a perfect reflection. It's very important to know that this line always passes through the vertex, right? Because the vertex is the highest point, so the axis of symmetry will pass through it. Lastly, we want to talk about the minimum or maximum value. The minimum, so this graph here, this parabola, has a minimum because the maximum, we're talking about the y values here. It goes up forever, but it doesn't go down forever. And the lowest y value that this parabola would achieve would be called a minimum. And this parabola here would be the opposite. The highest y value that this graph achieves would be called the maximum. Looks like we have one more definition. The parent function of the quadratic family is just y equals x squared. So parent functions, if you recall, are the most simple basic function without any transformations happening to it. The parent function for the linear family, for example, is just y equals x. And the parent function for the absolute value functions that we've graphed this year would be y equals absolute value of x. No transformations are happening. It's just the most basic function of its variety. And for the quadratic family, it's y equals x squared. So let's go ahead and graph this parent function, y equals x squared. In order to graph any quadratic function, what I want you to first do is to find the axis of symmetry. In order to find the axis of symmetry, remember that that's that vertical imaginary line that the graph passes, or that would divide our parabola perfectly in half. In order to find the axis of symmetry, it can be found at x equals negative b over 2a. What is a, b, what is all this stuff? Well, if you remember from the previous slide, I said that quadratics look like y equals ax squared plus bx plus c. So the parent function here, y equals x squared, the thing in front of x squared would be the a term, and in this case, the a would be 1, right? There's a 1 here. We know that if there's just an x or an x squared that doesn't have a number in front of it, the number in front of it is 1. Well, there is no b term, right? It doesn't exist. So therefore, the b term is going to be 0, as is the c term. Remember, I said there's no transformations happening to it. B and c are things that are going to cause transformations to occur. So if I told you guys to find the axis of symmetry, the axis of symmetry is going to be the vertical line. Vertical lines are written x equals negative b, well, b is 0, so negative 0, that's just 0, over 2 times 1. 2 times 1 is 2, obviously, and 0 divided by 2 is 0. So our axis of symmetry is at x equals 0. If you guys recall, x equals a number are vertical lines. If you also recall, I told you guys, if you're ever confused if it makes a vertical line or a horizontal line, to just make a t-table. This one says x equals 0. So the only thing that we know is that the x value has to be 0. You guys can pick any y value because there is no y value statement. So you could pick 1, 4, -3. It doesn't really matter. 0, 1 is here. 0, 4 is there. 0, -3 is there. You can see what line this is making, right? This is a vertical line. This line, everywhere along this vertical line, the x value is 0. I didn't do a very good job with something here. I'm always going to graph my axis of symmetry with a dotted line. So now it's dotted, we're good to go. Once you found the axis of symmetry, one of the things that I told you guys was that the vertex is going to occur somewhere along this axis of symmetry, right? Because this is the line, the imaginary line that divides it perfectly in half. That means that the x value has to be whatever you get from the axis of symmetry. Whatever number we got here, that's what the x value of our vertex will be. That's true for every quadratic function. So once you find the axis of symmetry, just take that number that you get and plug that in to the equation for x. And whatever you get out will be the y value there. So when we look at our equation, we have y equals x squared. All you do now is you plug 0 in for x squared, that's 0, 0 squared is 0. So the vertex will occur at 0, 0. And then once you have the axis of symmetry and the vertex graphed, what I'm going to have you do is take your vertex and put that in the middle of your table, 0, 0. And then count up from your vertex, 1 and 2, just, counting 1 more than 0 is 1, 1 more than 2, 1 is 2, and reverse the other direction, -1, -2. Now in this case, it happens to be the same 5 values that you would graph a linear equation with. But that's not always going to be the case, and we'll look at examples where that isn't the case. Once again, the reason why it's -2 to 2 is because we don't have a b and a c value. So what you're going to do from here is you're going to plug in 1 into x and see what you get out for y. Whatever you get out for y is going to go here. When you plug in 1, 1 squared is 1. You get 1. 1, 1. That's right there. Now plug in 2. 2 squared is 4. Now we could also go this direction. Keep in mind, when you substitute a negative in, especially now that we're dealing with exponents, you have to substitute it in or type it into your calculator with parentheses around it. So it's y equals -1 squared. And when you square the number -1, you get +1. And when you square the number -2, you get +4. Remember, these are supposed to be mirrors of each other. That's going to happen if your axis of symmetry is a whole number. If this number right here is a whole number or an integer, then they should be mirrors of each other. I'm going to go ahead and plot the rest of these points. So we have 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. You guys should be able to see that this is taking on a V shape or a U shape, like we described. It should not come to a point like the V-shaped graph. It should be rounded at the bottom. And there we've graphed a quadratic function. Specifically, we've graphed the parent function. I might come back to that slide here in a bit. Let's see a more complicated example of this. So on your questions, on your quizzes, on your tests, I'm always going to ask you for the axis of symmetry and the vertex. Remember, I told you guys the axis of symmetry can be found by doing x equals -b/2a. And if we are graphing this equation right here, we should be able to list the a, the b, and the c. Remember, the a is the value in front of x squared. The b term is the value in front of the x, which in this case is -8. And the c value is 6. So when we want to find the axis of symmetry is going to be x equals Negative b, well, b is already -8, so this would be like -8, which we know is +8, right? And our denominator would be 2 times a. Well, the a value is 2, so 2 times 2 is 4. So we get 8 over 4. Our axis of symmetry here is the line x equals 2. Remember, that is a vertical line where the x value is always 2. And if you are still struggling with this, remember what I told you guys. Make the t-table. All we know is that the x value is 2. So just fill in 2's, and then we don't know anything about the y value, which means we can pick it. 1, 6, -3. It doesn't matter. 2, 1, 2, 6, 2, -3. We can see that this is a vertical line, and everywhere along this vertical line, the x value is 2. Once again, I didn't make my line dotted, but I have this fun game that I can just make it dotted like that. Okay, so up next we need to find the vertex, right? We found the axis of symmetry, and now we need to find the vertex. One thing that I told you guys, if you remember, the vertex is going to be a point, and it has to occur somewhere along this axis of symmetry, which means its x value has to be 2. Okay, whatever you get for the axis of symmetry is also going to be the x value of the vertex. Now, to find the y value of the vertex, you are going to take 2 and plug it into x there and see what you get out. Remember to plug 2 in with parentheses around it. And your calculator should be able to handle this whole thing in one line. You don't need to break it up, type it in a bunch of different ways. It would be like this. 2 parentheses 2 squared minus 8 times 2 plus 6. So we should be able to go ahead and type that whole thing in, as long as we're using a decent calculator. Like your iPhone calculator probably will not get this correct, but a decent calculator will. And when I type that all in, I get -2. Hopefully you're following along and you also got -2. So I'm going to go ahead and plot the vertex. That's at 2, -2. Next step. Go ahead and make a t-table. X, Y, and put 2, -2 as the middle point. 2, -2. And then fix the x's so that this is in the middle, right? 1 more than 2 is 3, 1 more than 3 is 4. 1 less than 2 is 1, and 1 less than 1 is 0. So I'm going to go ahead and plug these numbers in. Remember to x in my question. I'm just going to drag this down so I can see it, don't have to scroll. Once again, your calculator should be able to handle this all in one line. Here's a couple tips for you. If you go like this, 2, we already did 2. I'll just do 0, even though you should know what it is. 2, 0 squared minus 8 times 0 plus 6. You should be able to type that into your calculator. 2, 0 squared. Be very, deliberate. Type it in just like I have it. Minus 8 times 0 plus 6. You type that in, you should get 6. You should also be able to reflect this to the 4, and you would also get 6, right? I could also double check that, but what I wanted to show you guys the trick is if you type up on your TI calculator right now, if you push the up arrow, or depending on your calculator, you might need to push second and then the bottom right button, which is entry, and it'll re-bring it up. And then you can just change the number to 1. And when you plug in 1, you get 0. I could also plug in 3, right? Plug in 3 there and there, I would also get 0. So I'm going to plot all these points. 0, 6 is up here. 1, 0 would be right there. 3, 0, and 4, 6. So we can see this graph. It is a little more steep. If you guys remember this from the last unit, we call that a stretch. It's a little bit more steep of the U, but still making that U shape. And I'm going to have specific spots for you to tell me what the axis of symmetry and the vertex are. Remember, The axis of symmetry is the line x equals 2, and the vertex is the point 2, negative 2. I am also going to request that you guys tell me what the domain and the range of this graph would be. Remember, anytime I'm asking you guys to graph something, I'm also asking for the domain and range from here on out. So the domain. If you recall, the domain is what x values does this graph ever exist at? So you should be able to think of this by saying, hey, does it exist out here at -7? Okay, would this graph ever get out here to -7? And yes, it's mostly going up, but it's also going left forever. You could plug in, another way to think of this, could you plug in -7 into this x and this x? Absolutely, you're going to get a number out. It's going to be really large, but you're still going to get a number out, right? Could you plug in -100? Yes, you can. Okay, you can plug in anything for x. There's nothing that's stopping you from plugging in a huge number for x. Hugely negative or positive for that matter. This graph has an unrestricted domain. It goes left forever and right forever. Remember, the notation that we use for that is we say all reals, and it's an R with an extra vertical line. All quadratics, everything that you graph in this chapter is going to have a domain of all good numbers. Okay, all of these graphs go left forever and right forever. However, all of them are going to have a restricted range. The range is not going to be all reals. Remember, the range moves up and down and asks what y values does this graph ever achieve. And this graph here never goes anywhere below the vertex. Okay, it goes like this. If you follow it from left to right, it goes like this, right? Hits the vertex and then bounces off of it. So the minimum y value that this graph ever achieves would be -2, and then it will achieve everything greater than -2. So it does achieve -2, right? So we get the or equal to sign. Y value is greater than or equal to -2. You're going to pick up on this pattern here, that this value right here, the y value of your vertex, is also going to be reused every time for the range. The domain will always be all reals, and the y value will always borrow from the y value of the vertex. It might be greater than, it might be less than, but the number is always going to be the y value of that vertex. Let's look at another one. Identify the axis of symmetry and the vertex once again, and then graph it. You're also going to need to tell me the domain and the range. This would be a great one for you to pause and try on your own, see how you do, and then push play and and grade yourself on it, right? Okay, one thing I like to do is I like to list the A, the B, and the C. The A value here is 1. The B value here is -2. And the C value is -1. Okay, so we need to identify the axis of symmetry. The axis of symmetry can always be found at x equals -b/2a. This, if you haven't picked up on this, is something you're going to need to memorize. X equals -b/2a. So our b value is -2. When you plug in -2 into -b, that would be +2. And then plugging in 1 in for a, that would be +2 as well, and we get 1. Our axis of symmetry here is going to be x equals 1. X equals 1 is a vertical line, and it's a vertical line where the x value is 1. That would be right there. Remember what I told you guys. You do have the ability to make a t-table with the x values being 1, and you pick the y values. So one of the things we need to do is identify the axis of symmetry. The axis of symmetry is x equals 1. Up next, we need to find the vertex. What I told you guys is the vertex will always use this value. Okay, the vertex has to exist on the axis of symmetry. In the x values everywhere along this line are 1. So we know the vertex has an x value of 1, and to find the y value, just plug 1 in here and here. Remember to substitute it in with parentheses, and remember your calculator will be able to handle it all in one line. So if you type in 1 squared minus 2 times 1 minus 1. It's going to give you the right answer. 1 squared minus 2 times 1 minus 1. What do we get? I got negative 2. Hopefully you guys did as well. 1 comma negative 2. Vertex is 1 comma negative 2. I should be able to plot this. That's right there. Up next, go ahead and make the t-table. X, Y, put 1, negative 2 in the middle, and then count above 1. That would be 2 and 3. And below 1, that would be 0 and then negative 1. Now plug these values in for x in the equation up here. I'm going to once again bring it down so I can actually see it in one frame. So you should be able to type these into your calculator, putting these values in for x. I can plug in 2, for example, or I could think about it. Either one's fine. 2 squared is 4. And negative 2 times 2 is negative 4, right? So 4 minus 4, and then minus 1, that will be negative 1. Because this is your axis of symmetry, right? These should be mirrors of each other. I don't know if they did that. It's kind of confusing now. There we go. So if 2 is negative 1, 0 should also be negative 1. And it will be. 0 is also just really easy to plug in because it wipes away this and this. So it's just whatever the C value is. And then I can plug in 3 as well. You guys should be able to do this in your head, but once again, your calculator can do it as well. 3 squared is 9. Plugging in 3 there, you subtract 6, and then minus 1. 9 minus 6 is 3. Minus 1 would be 2. These are mirrors of each other, so you can fill in the top and the bottom. So let's go ahead and plot these points. 1, negative 2, that's the vertex. I've already plotted it. 0, negative 1, and 2, negative 1. And then 3, 2, and negative 1, 2. So my parabola looks like that. All right. Last step for this problem is we need to be able to list the domain and the range. Now remember, the domain for all of these graphs is going to be all real numbers. This graph goes forever to the left and forever to the right. Even though, yes, I know it mostly looks like it's going up. For every little bit it goes up, it's also moving to the left a little bit. And it's going to move to the left forever, and it's going to move to the right forever. So the domain is all real numbers. Now with the range, remember we're talking about the y values, what it's doing moving downward and upward. So the range of this graph, it's never achieving anything down here at the negatives, right? As this graph goes from left to right, it's going this direction, this direction, this direction, right? Hits at negative 2, it then bounces up and goes up forever. So the range for this function would be y values greater than or equal to negative 2, right? No y values in this chunk are ever reached, right? This graph will never reach. I could extend this forever this direction and forever that direction. It's never going to get below negative 2. That's the minimum it reaches, and then it bounces back up and goes up forever. So the range would be y values greater than or equal to negative 2. Let's just do, we're going to call that that good. If you guys have any questions on 4.1, I would love to answer them. Please check in with me and let me know what you guys are coming up with.